Hello, everyone, and welcome to the Earth Networks 2021 Summer Outlook webinar. We're going to be getting started in just a few moments as we wait for everyone to join. Hello again, this is the Earth Networks 2021 Summer Outlook. Thanks for joining us today. I'm your moderator, Anna Porteous, Director of Marketing. We will be taking questions at the end of the session. If you would like to ask a question, please use the question section on the GoToWebinar control panel. And if you have questions or need more information after the webinar, please email us at info@earthnetworks.com. Participants are in listen-only mode, and this webinar is being recorded. All registrants will receive a link to the recorded webinar and slide deck in an email after today's session. If you can't hear us, please make sure your speaker volume is turned up. You can also listen to the audio by choosing Join by Phone in the audio section of your control panel. If you're still having trouble, close the application and restart. We are Earth Networks, a member of the Advanced Environmental Monitoring family, and we operate the world's largest proprietary weather observation and lightning detection networks. Our vision is a safer, more prosperous world, and we help global organizations automate decisions through weather intelligence. Each spring, our meteorologists analyze trends and all kinds of weather data to create the Earth Networks Summer Outlook. It's a collaborative effort backed by this amazing Summer Outlook team. We provide 24/7 custom threat forecasts and seasonal outlooks like this one for major sports teams, schools, aviation, and enterprise clients. Today's webinar will be presented by meteorologist Andrew Rosenthal and senior meteorologist Chad Merrill. Meteorologist Andrew Rosenthal joined Earth Networks in 2006. His work focuses on weather-related journalism, data quality control, and operational forecasting. Senior meteorologist Chad Merrill joined Earth Networks in 2008. He produces custom forecasts for a wide range of clients in the US and around the world. And now it's my great pleasure to hand it over to Andy.
Anna, I'm not able to click forward. There we go. Good afternoon, everyone. Before we get into this summer's outlook, let's take a quick look back at our forecast from last year. Summer temperatures in 2020 were forecast to be above average across the West and along the eastern seaboard into the Ohio Valley. In general, this is what we saw. In fact, portions of the desert Southwest and New England saw record warmth last summer, with most of the West and eastern seaboard above average to well above average. So here's an interesting thought. How often did temperatures stay above 70 degrees last summer? So I picked that number because, at least to me, that's the threshold where I feel like I might need air conditioning on all night. As you can see, the Gulf Coast and the eastern seaboard saw these warm nights the majority of the summer. But as you get inland, the numbers drop off rather quickly, with Kansas City and Cincinnati, which are at similar latitudes to Washington, D.C., seeing a third to half as many of these muggy nights. On the rainfall side, we forecasted the West to remain quite dry, while the eastern third of the U.S. would see above average rainfall. The actual rainfall shows this, with many areas from the Great Basin to Texas seeing their driest summer on record. On the other hand, an area from the Gulf Coast to the Mid-Atlantic saw well above average rainfall. Why was the Southeast so wet last year? A lot of it was driven by the showers and thunderstorms that formed over the summer, but another reason was the tropical season. In 2020, we actually broke numerous tropical records. We saw 30 named storms overall, which was a record. Of these, 11 made landfall in the United States, and a record 4 landfalls occurred just in the state of Louisiana. And as you can see here, many of the storms that did hit the United States followed what's a typical track for tropical systems into the Mississippi Valley and Ohio Valley and Mid-Atlantic, which on the previous slide you could see is where we had the heaviest rainfall. So 2021 is a special year weather-wise. The normal high and low that is in the weather report each day is actually a data set of 30 years, of which the data is an average of those temperatures. So this average is recalculated every 10 years. The most recent normals were updated from a data set that covered 1981 to 2010 to one that covered from 1991 to 2020. And NOAA publicly released the new data set just a couple weeks ago. So we thought we'd briefly talk about some of the changes we're seeing between the old and the new data. On the temperature front, nearly the entire lower 48 saw warming, with the largest warming across the Southwest. Other areas, including the Midwest and Northeast, saw warming as much as a degree in the new data. As far as rainfall, summers have gotten much drier from Texas to the Pacific Northwest. We do see a little bit of a wetter anomaly that developed in the Colorado River Valley, but this was largely due to a couple of wet summers in 2013, 2014, 2015, and 2017. Meanwhile, areas from the Gulf Coast to the Northeast have gotten somewhat wetter in the last 10 years. As far as the warming, much of it has come at night, where the US has seen their normal lows climb in the new data. Daytime temperatures have climbed from the west to Texas as well as across the Northeast, but we are actually seeing a stripe where the average highs during the summer have decreased slightly from the Dakotas to the Gulf Coast. There's any number of reasons for this going on, including storm track that might have allowed for more cloudiness during the day. As you can see, the average temperature across the United States has been warming over the last 30 years. While there is variability in temperatures, in general, compared to the long term, the average has increased. And if you look at this chart, the 1 year that is well below average, just in case you're curious, 1992, was from Mount Pinatubo erupting in 1991, causing temperatures around the globe to decrease by 1 to 2 degrees. So now I'm going to turn it over to my colleague, Chad Merrill, who will walk us through the summer's outlook.
Thank you so much, Andy, and you presented some great information on the new climate normals across the US. Now, folks, our summer outlook this year does include September because September is typically a warm month across the US and more of an extension of summer, if you will, past Labor Day. So we did include September in our forecast going forward for the temperature and precipitation trends that we are going to see here in our slideshow. So we think that the strongest signals for this summer is in the recent climate data, the recent 10-year trends in temperature and rainfall, and the drought conditions across the US. We put a lot less stock into the ENSO pattern, ENSO being El Nino, the neutral phase, or La Nina that you typically hear in the news every year. Also, we put a little bit less stock in the climate models. Those tend to show some anomalies that are fairly persistent from season to season. So when we look at the last 10 years, folks, take a look at the temperatures compared to the most recent averages, 1991 to 2020. Temperatures over the last 10 summers have been above average across much of the US, strongest signal across the West and the Southern Plains. Now, as for rainfall, we see the dry signal across much of the Mountain West, a little bit of a wet signal across the Southwest parts of the US, and that was because of what Andy mentioned a couple of slides ago, that there's been a couple of anomalous wet summers. We do see that precipitation or enhanced rainfall across the east. And really, folks, when it comes down to it with rainfall, especially once we get later in the season, any tropical system that just lingers off the coast can create the amount of rain that you need for an entire summer in a couple of days. Florence was an example of that across eastern North Carolina. So a contributing factor to the wet anomalies that we see from the Gulf Coast to the Mid-Atlantic is because of tropical systems. When we look at a couple of cities here, now, you know, Los Angeles doesn't typically see much rainfall during the summer, But it is interesting to note that when we compare the previous climate normals to the current climate normals, that the rainfall in Los Angeles during the summertime, and this is going from June through September, has dropped by 41%. Phoenix rainfall has dropped 10%, Salt Lake City 12%. Seattle was the only location that saw an increase in rainfall. And part of that could be due to storm systems. The jet stream migrates to the north in the summertime, so you don't get as many cold fronts that swing across the US. But Seattle is far enough north where they can catch some rain from cold fronts and frontal systems that skirt across Canada. When we look at the central and eastern parts of the US, we see rainfall has increased as much as 10 to 11%. New Orleans and Washington, D.C. A contributing factor to that would be tropical systems, enhanced tropical systems, or the number or frequency, especially when we get later in the summer. Minneapolis, even Birmingham, has seen an increase of rain of 2 to 8%. So there are some of the statistics when we look at the previous climate averages, and we compare them to the current climate averages. Now, across the eastern US, July is typically the wettest month overall. So the 1991 to 2020 mean for the eastern US rainfall is about 4.5 inches. But even though September is considered one of the drier months of the summer, notice that it has the highest wet anomaly, 8 inches. And that's because a tropical system can easily displace the average and create some of the very high numbers that you see on that chart. But what happens is, as convection or thunderstorms develop, the peak for thunderstorms across much of the eastern US is in July, because that's when temperatures and humidity are the highest. And then the thunderstorm season slowly diminishes once we get into September, but the tropical season picks up. But those tropical systems tend to enhance the rainfall in certain spots, but not typically overall across the entire east. It just depends on where those tropical systems make landfall or spread their moisture. So on average, in the east, July is the wettest month, but September can have some higher anomalies because of tropical systems as well. So let's take a look here as we move further into the decadal trends and the minimum and maximum temperatures. Overall, low temperatures at night have gotten warmer across the entire United States over the last 10 summers. Temperatures at night, or temperatures during the day, have increased in the west. Part of that is due to a drought situation that typically develops in the west, just as we saw a couple of years ago in 2019. But when you have dry soil readily heats up during the day, so your temperatures can actually spring above average. The reason that we're seeing temperatures during the day closer to average from the Gulf Coast to the Mid-Atlantic is because of the clouds and rainfall, which leads to some somewhat lower temperatures during the day. But wet soil tends to keep the heat in, so that's why you have warmer temperatures at night. So it's that rainfall, enhanced rainfall, that's causing that anomaly from the southern parts of the Mississippi Valley all the way to parts of the southern Mid-Atlantic. You wonder how common 90-degree days are in the summer. Well, along the coast, you would think, well, maybe, eastern North Carolina sees quite a bit. Well, the influence of the ocean actually only brings that number to about 5 there in eastern North Carolina. But when you get farther south, Tampa and Miami, 59 to 75 days, temperatures at or above 90. Mid-Atlantic has seen quite a few, 33 in Washington, D.C., but you go across the mountains to Pittsburgh and it's only 14. Interior parts of the U.S. tend to see significant warming during the day, and that allows for temperatures during the day to spring above 90s. That's why we see those 30 and 35s between Denver and Kansas City. Denver is one of those unique cities where you get some really warm days in the summer, you get some really cold days in the wintertime. They have quite a variance in temperatures, and in the Southwest, you can see as much as 110 to 119, like most of the summer, basically from June through September, where your temperatures are above 90 degrees. And along the West Coast, it hardly ever happens in Seattle and San Francisco. The drought is hitting home across parts of the South and West, extreme to exceptional drought, which is widespread crop loss and widespread water shortages that continues to mount. We also see some dry problems developing across the northern plains and some patches of an anomalous dry weather from the Great Lakes into parts of New England and even here across the North Carolina coast. So as we take a look at the Western US and specifically compared to last year, the drought, the percent area of land that is impacted by drought is up from 39% last year to 83% this year. But when you take a look at the extreme and exceptional drought, where the water shortages are, where the crops have basically, the crop loss is basically at the highest point because of the shortages of water, we're talking about a difference here of about 44%, 43% for extreme drought and 22% for an exceptional drought. So we are in a dire situation across the Western US when it comes to the latest numbers. Here's a little graph, folks, that shows where we stand with the exceptional drought this year compared to the last 10 years. So this is the percent area of land that is seeing this exceptional drought. It's the highest it's been in the last 10 years across the western parts of the US. What happens when you have a drought of this magnitude? Well, first of all, the soil is depleted of moisture, so there's less evaporation. Evaporation leads to cloud cover and rain and thunderstorms, so you get less cloud cover, so the sun heats the ground and causes temperatures to rise. So it's a drought, it's a feedback situation. Drought feeds on itself, and that there's very little in the way of moisture to evaporate to create the clouds. So when you have a situation like this, you tend to see the drought persist until you have a large scale pattern change. And in the Southwest, the monsoon, many of you probably have heard the monsoon, but basically when Arizona heats up into the 90s and 100s, what happens is you get this difference in temperature between the landmass and the Gulf of California that triggers these showers and storms. Well, this particular pattern is called the monsoon, and these showers and storms that develop typically reach peak in July and August, the most frequent time of the year to have these showers and storms. That's why you see the high numbers here with rainfall amounts across Arizona and New Mexico. As a matter of fact, the monsoon season accounts for almost 45% of their annual precipitation, July and August being the height of the monsoon season. So they really rely on this rainfall over the summer to keep things going there. Well, when we look at the last 10 summers, 2013, 14, 15, and 17 had above average rainfall, but in the May preceding each summer, the only year that had any bit of extreme drought in Arizona was in 2013. That number was well below 1%. Where we stand right now in May of 2021 is 31%, and we are rising. So we have an exceptional drought going into the summer, and because of the drought feedback situation, we do expect there to be less rainfall than average because of when the monsoon rains hit in July and August. We also looked at a couple other factors as well, and temperatures along the Gulf of California are below average, and that was another factor in the 2019 drought across the Southwest. But drought is the leading factor as to why rainfall should be below average going through the summertime. Soil moisture anomalies, when you see these negative numbers, that's dry soil. That's expected through the end of August. And this is the latest drought outlook that shows we have widespread drought across the West that will persist through the end of August, and drought will develop in areas that are seeing a little bit less in terms of rainfall deficits. So this is going to be a big story over the summertime. And once we look east of the Rockies and the Front Range, we see very little way of drought development going forward through the summertime. A less factor because El Nino and La Nina don't really contribute much to the overall pattern across the US, but we are right now in a neutral phase, and this is just an example of what a neutral phase is. This is the temperatures in the equatorial Pacific. That means they're near average when they're neutral. El Nino is when you have a warming of the equatorial Pacific, and La Nina is when you have a cooling of the equatorial Pacific. So when you take a look at those three images and then take a look at the latest image, we're right smack dab in average. We are seeing a neutral phase, and that is going to continue through the summertime. And all the models show that as well. And that'll even continue through September, this neutral phase, near average temperatures. So our team of meteorologists identified certain years that look similar with a neutral phase ENSO, and precipitation or rainfall tends to be above average across the Gulf Coast, Mid-Atlantic, slightly below average. As we head to New England, well below average or I should say this is temperatures. So well below average temperatures, not precipitation, across the mid-Atlantic and southeast. A contributing factor to that would be enhanced rainfall, which we see some dark blues here. There are some areas that had some negative anomalies. In the summertime, you're not going to get widespread precipitation like you get in the winter. So there will be some patches of below average rainfall, but in general, we see a wet signal across the southeast. Now, across New England, temperature anomalies slightly above average, and that contributes to some dry soils because of a slightly below average rainfall. And then in the west, there's a big signal for it to be not only warm, but also dry when we look at neutral ENSOs. This is one of many climate models that shows much of the US above average for temperatures and then below average for rainfall here across the west and parts of Texas with above average rainfall as we head through the parts of the Ohio Valley. You know, some of these little spots here are just hit and miss, but we see a bigger signal here across Florida and parts of the southeast for above average rainfall. So here's what I really want to hit hard on is our rainfall outlook. The western drought will continue. It will also lead to an active wildfire season. So as we get closer to July, August, and especially in September, those wildfires develop, and we could potentially see several fires that develop and smoke move across the country, just like we did last year. The southwest monsoon, unfortunately, we see less rainfall than average. Thunderstorms and tropical moisture will be the contributing factor to above average rainfall in the southeast and in the mid-Atlantic. And again, July is the month for thunderstorms, and September is usually the peak of the hurricane season. And that period from late July through September, we would likely see enhanced tropical moisture from the Gulf Coast to the southeast. We do think that interior New England will stay abnormally dry, and there's some mixed signals for rainfall in the Midwest, Ohio Valley, and parts of eastern New England. As for temperatures, we think that most of the West will be above average. Again, it's that drought feedback I showed you earlier, where temperatures during the day will be above average and even overnight lows. We do think that the warmth will be pretty predominant across much of the Midwest and the East. The warmer nights, because of the soil being wet from above average rainfall, will likely contribute to those warm, muggy nights across the East and enhanced rainfall potential there from the central Gulf Coast. But we do see two areas where we have mixed temperature trends, and that is the central parts of the Mississippi Valley, and that would be due to enhanced rainfall that causes temperatures during the day to be slightly below average, more so below average than overnight lows. So this is not due to cold air coming south. This is just due to, because we see an enhanced risk for rainfall, we think that there could be maybe more closer to average temperatures, but temperatures wouldn't vary too much because when you have a wet soil at night and during the day, your temperatures won't budge too much. And here, the stripe here across the upper Mississippi Valley, there's some mixed signals, and there could be an occasional cold front that comes through parts of Canada that spreads maybe somewhat cooler air that grazes parts of the northern US. But again, cold fronts aren't that frequent once we get into the summertime months, but that's just one area that could see potentially near average temperatures. So with that in mind, I am going to turn it over to Anna, and she may have some more information for you as well as some questions. Anna?
Thank you so much, Chad and Andy. That was a really great presentation. So now's the time when you can enter in your questions, and I invite everyone to put them right in the question panel here. So we'll look through them right now, but it's time for questions. And the first one is, will 100-degree temperatures be common this summer? And if so, where will they likely occur?
So we did talk about the 90-degree days. And 100-degree days, if we can flip here to the next slide, aren't too common across the US, but we do notice that in the parts of the Southwest US, that Phoenix averages about 117 days of temperatures at or above 100 degrees. Because of the drought situation there, we do think that there will be more than 117 days where temperatures are above 100 in Phoenix. Now notice that temperatures, there's only 3 or 5 days from the Mississippi Valley to the east that has 100 degrees or higher. And the only way to really get a 100-degree day is if you have a dry soil and you have extended period of dry weather and sunshine. And I don't see an upside risk to more than average 100-degree days across the southeast. The only place I see it is the west because of the ongoing drought. So 7 would be the number, Denver, 5, Salt Lake City, a little bit higher once you get into the California valleys and parts of the Great Basin too. So I think this chunk of real estate here from about the Central Plains into the Southwest would have more than average 100-degree days this summer.
Okay, thanks. The next question is, what is the typical warmest day of summer?
All right, so the typical warmest day of summer across much of the US as we go here. First of all, this is a look at the summer minimum and maximum temperature trends. And notice how we see that influx of warmer air, June through September. We see that trend from 1991 to 2020. And we look at minimum temperatures and they've actually risen as well. So when you look at the overall grand scheme of things, it's usually before the monsoon season kicks in the Southwest. So June 16th, early July. July for much of the West. Later in the summer, August through late September across much of the West, along the West Coast, I should say. And then the height of summer, the hottest temperatures usually occur in the early part of August across the Western Gulf Coast. Of course, if you get a tropical system, that would delay that a bit. And then mid-July through early August for much of the Midwest and much of the East. So early or mid-July here across the Northeast, and then late August across parts of South Florida. So usually it's the weather patterns that dictate when we have the warmest day of the year, and it's before the monsoon season kicks in the Southwest. During the height of summer in July across much of the rest of the nation, and usually that late July period to the first part of August, also known as the dog days of summer, which is contributing to the hot weather. Well, the dog days comes from the dog star, but anyways, it's basically the mid part of July to early August is what the dog days refer to.
Okay, the next question is, actually I'm getting some feedback, so one second. All right, let's see if that's better. Nope, that's not better. All right, let's try it one more time here. Even though the tornadoes are most common in spring across the plains, where are they most likely to happen in the warmest part of the year? In the summer? And Chad, I've muted you. I'm going to unmute you now. Sorry for that.
All right, so yeah, tornado season we usually think of as March through May across much of the nation's midsection. And as we go forward here, the average number of tornadoes from June through September, you saw that stripe of 30 to 33 across the midsection, the nation's midsection. Tornado season is more prevalent once you get into the later part of the summer. So 33 is the number across Minneapolis, 26 in Des Moines, Iowa. So the numbers are much lower in the West. Now, one thing to note is the Western US, even in a dry pattern, can get these thunderstorms that develop just because the mountain terrain forces the air up and it rises and creates these thunderstorms, even in a drought situation. But the problem is you get more lightning than rain, and those lightning strikes are what creates some of the wildfires. But you don't get enough moisture in the atmosphere to create enough spin that would generate tornadoes. So there's very few out west. It's across the nation's midsection. The mid-Atlantic, the heart of any tornado season would be July, 6 on average across Maryland, 11 in Pennsylvania, very few as you go north. But the heart, the most tornadoes usually occur here, even across the nation's midsection. Of course, the numbers are much, much higher March through May than they are June through September. but still 30 to 33 across the central and northern plains is a pretty significant number compared to the other parts of the country.
Okay. I'd like to thank everyone for attending today. That's actually, we're at the bottom of the hour, so we have to go. But if you have any questions, email us at info@earthnetworks.com. I'd like to thank our panelists, Andrew Rosenthal and Chad Merrill, and I hope everyone has a wonderful rest of your day. Thank you so much. Bye.